All right. I think we'll give it a few minutes for folks to join the call.
Mon, did you end up putting your LinkedIn into the
I struggled with getting good results from it. I have done that a few times, but for some reason it doesn't. Tried like 3 times, and my LinkedIn is not the strongest on it for some reason. But other
Okay.
people's sounds good. Yeah. Have you done that one?
I think I'm too embarrassed.
Oh, you should definitely try that
Yeah,
use
I'm too
case.
embarrassed to try it.
Okay. I think we have enough we've got enough folks in the room now. So maybe what we can do is just like to kick off, I'll just do like a quick intro. My name's Aman. I'm on the product team at Arise. Um, and I'm joined here by Harrison. Harrison, you want to do a quick intro of yourself?
How's it going, everybody? I'm Harrison. I'm the director of engineering here at Arise.
Awesome. So this one is pretty exciting. I feel like we're trending more in this direction as, you know, maybe it's indicative of the space overall. Research is still super interesting. It's great to follow research, but we thought we'd um, do a little bit of a turn on that journey and deep dive on a product that has definitely taken the entire AI space by storm, and that is NotebookLM. And what we thought we'd do would be to deep dive on the product itself and speculate internals around how it works. So keep in mind, some of this is going to be from the outside in. We're taking resources that we found across the internet, across interviews from product managers of the product, um, and honestly, a lot of Reddit speculation and sort of synthesizing that into the product teardown you're about to see. So it should be great. It should be interesting. We'd love any engagement as well in the chat. So feel free to drop questions, thoughts, tell us we got something wrong, and we're happy to debate it real time as well. Cool. Let's hop in. So I think good place to start is Notebook LM. What is it? Um, so if you haven't seen the product yet, you can just sort of pull it up in real time. And what's interesting is it's a pretty simple interface product launched by Google. So this is actually maybe one of the first non-chatbot products in the AI space that Google has launched. And the way it works is you have a sort of product primitive of a notebook. They even have the experimental tag on it. So it's like it's an early version of the product. I don't want to like set super high expectations.
Very
And what you can
Google.
do, yeah, super Google, right?
Very Google.
Yeah. And what you can do is drop in any type of, most file types are supported here. So you could do PDF, text, audio. A really cool feature they launched last week as well is you can actually drop in a YouTube link. And with that context, if you copy over some text, you'll be able to actually insert that here. And what you get on the output is let me see if I can pull up one I already have. I think I need to go back here. What you get on the output is actually an audio file that converts. Oh, I think I actually just use one of the examples. It actually converts the context into a format called a notebook, which you can then use to create this audio file, which produces a very, I'd say like extremely realistic sounding podcast episode based on the text. Um, so Harrison, I don't know if you want to just maybe play like a short clip from your end, just to like for folks that maybe haven't tried it out, just to get a sense of like what it sounds like.
Sure. Yeah, and I guess I can also share maybe my use case
Oh, there you go. Thanks.
that I've been super excited about. Like a few weeks ago, the team and I were trying to think about ways to make substring search faster in our database. And it's just one of those things that if you're like most people, like myself, it's kind of a grind to read a bunch of Wikipedia pages on related algorithms, see what the common thread is. But with NotebookLM, we had this really interesting experience where, okay, we knew we had 2 or 3 algorithms we were interested in. Maybe we also took some inspiration from grep, from Unix, and wanted to have a pretty high level synthesis that can tell us what the algorithms are doing, what the key takeaways are. So loaded these 3 sources, generated the audio, took about a few minutes, and in the end, we could just put it on and listen to it while we went on walks and slowly digest it in a different form factor. I'll try and play the audio. It might not be the best through Zoom, but I'll give it a go.
Ever feel like your code's like stuck in slow motion, just spending way too much time hunting down a specific bit of text?
Oh, absolutely. It's a classic programming headache. You're basically trying to find a needle in a haystack of digital words.
Exactly. And today's deep dive is all about getting that needle fast. We're talking about algorithms that can seriously speed up your search.
So I'll just stop there. Hopefully it comes through. It was, for me, a similar experience when like the 2022 ChatGPT experience where you couldn't believe on the other side of the screen was not actually a real person. And I think that sort of feeling is even more intense because it's a very specific topic you care about. And it's these two really, really professional, polished voices talking about it. And you know what? The information quality was really dense too. I got a lot out of that 10 minutes, enough to go and then dig deeper into these algorithms and kind of go from there. So that was kind of my exposure to it in the first rev, and I was just blown away.
Yeah, I think I highly recommend everyone to go and try it if you haven't yet. It does take a couple minutes to load up the audio file based on the context. But what you'll find is there's like a few components to this that when you listen to it, we could try to break down as being great parts of a product and try and understand how those parts work. So kind of what Harrison is alluding to here as well is the quality of the transcript feels perhaps a step function higher than what we've seen from your LLM chatbot interfaces. There's definitely some prompt engineering going on underneath the hood, but more likely this is actually a multi-step agent system or a multi-step prompt system that takes some context and generates essentially 2 sort of sources of transcript to actually create this dialogue between 2 agents, or two at least what sound to be 2 different agents.
Well, Aman, hold on. You should talk about, because what you're saying earlier, this is us from the outside looking in, right? About, we were talking earlier about, well, how do they even generate the scripts? Let's not even talk about the voice. How's the script generated? And then we went through this, maybe talk a bit about like the ways we tried to not necessarily hack it, but get the 2 AI podcasters to tell us about what the internals were, and with the show notes from the future.
So given that we're AI people, I think the first thing we tried to do was break it. We tried to break this experience, right? Maybe that's like indicative of how we think about things, but we were trying to open the box, see how it works. So what we did is there was this prompt floating around online that you could feed in that was sort of this almost like a way to try to get at what we think is the system prompt. So the context is you basically provide some text that says it's the future now. And the way that this system works is this is a podcast episode. So what you can do is prompt it and say, in 10 years into the future, it turns out that this podcast is actually 2 AI bots talking to each other. Now, tell us about that and give us a podcast episode on that. And it's really interesting because you hear what sounds like 2 voices saying, oh, like we're realizing we're AI and like how does that work? And then they start kind of like, this dialogue starts to trend towards speculating, well, it turns out that there's a system prompt and a multi-agent system, and these texts go into each other. And then you kind of realize, like, is this really how the system works? Or is it actually just a hallucination of the system of what a system prompt could be in this case? So it is very much this like interesting we're trying to figure out how do you, aside from just the engineering and product side, how do you kind of like even get the system to sort of break? And there's been other examples of people online posting like 1,000 random words from the internet and dropping it in, and it creates this like almost like jumbled up, like almost like nonsensical product like podcast episode where you're just trying to like connect dots that aren't meant to be connected. So yeah, a lot of ways to try to break this thing. Highly recommend, try it out yourself. But yeah, we don't actually, to Harrison's point, you know, how the transcript is generated is our own speculation as well. That these are, two distinct transcripts that are created from an agentic system.
I think one of the I think he's a developer advocate on the Hard Fork podcast did maybe reveal a little bit about it. I think there is a component of like, there's a first pass that generates a script, and then there's like a critique phase, and then there's an incorporation of the critique to this. So there's like a multi-step, almost agentic system happening there to produce the transcripts. There's also an interesting step where I think they then add what they're calling disfluencies, like the ums and the ah and stuff that just makes the speech sound more natural. Yeah, like before we move on, there's another question I wanted to ask you from a product perspective, and I guess I'll show the NotebookLM UI again. What's interesting is like the by the way, for anyone who's going to try it later, if you go on this page, you're not dumb, but like Google, in the most Google fashion, buried the best feature under this notebook guide. So you have to bring this up. But what's most interesting is like, I think when they first shipped this product, it was going to be like a chat over docs feature, right? Like you can now, like I have this like doc over my Dungeons and Dragons notes. I can theoretically ask it questions about my doc, but no one talks about it, right? Like no one's excited about this chat over docs thing. Everyone's excited about this audio that you can generate from it. If you take your product lens, why do you think that is?
Yeah, I think my honest take is kind of like Chat GPT as well. The Notebook LM moment feels like it's like the product is having a moment, but sort of by accident. And so the product was designed in a way that if you look at, what did ChatGPT do well? It's this chat interface. Okay, if you try to replicate that over docs, you're going to copy over some of the UI. But that's actually not necessarily the novel feature behind this. What's novel is that transcript generation and the state-of-the-art audio model underneath it that's producing the super realistic sounding, high quality audio. So my take on that is it this really was it really does kind of feel like the product is having a moment sort of by accident, in that it's not necessarily great at the thing it was supposed to be good at, but it's excellent at something else, which is, this uncanny valley of a really high quality podcast discussion. And we'll talk about the quality of the actual, podcast in a bit, but perception wise, high level, it just feels super novel and new as a format. So I think that's my take. Like, I don't know if it was intentionally designed to be, the experience was catered around or centered around the experience that it is now. So
yeah,
cool. Yeah. So, and I'll share a couple more tidbits or anecdotes of the transcript. A couple other fun use cases you can try, which Harrison and I were talking about earlier, is like you can drop your LinkedIn profile in. What's interesting though is if you just drop your LinkedIn in, it's not going to be that great because the public, surface area of your LinkedIn, like LinkedIn blocks things. But if you just copy paste all the text on your LinkedIn as the source, what you end up with is what feels to be a super personalized, rendition of your career history. And I think that is one of the examples of use cases that really blew people away is, yeah, you should use this thing as an educational tool, go learn about a new topic. It's it's engaging in a new way to learn, like Harrison's earlier use case of like trying to understand this paper, which is what I think it was intended for. But when you personalize it, it ends up becoming so powerful. Because I think that there's something, I mean, humans in our egos, I think that there's something to hearing about, hearing two people talk about you and like rationalize career decisions that you've made, or like, oh, it's so clear, like Harrison was this, doing an incredible job at like Lyft, and now he's at Arise. Like, so you get this like really interesting story that feels personalized. And that I think is a bit of an aha moment of use cases that started making a lot of waves on the internet around how you can use this tool. I think the other component of this is the transcript generation, or the transcripts themselves sort of present ideas in a way that feel kind of new. And what I mean by that is it's almost like they're scratching at humor. They will use sort of tools, or like implement sort of like the model itself will implement sort of um sort of turns of speech that we take for granted, things like alliteration. um so it's like, oh, this is the president of prompting or something like that, and things that feel very human like. So I think that is kind of novel as well in this case. So that's my last couple notes on the transcript part. I guess anything else to add on to that?
Yeah.
Cool. Okay. So aside from being a pretty impressive back and forth transcript, I think the second component of this product is the conversation quality, and specifically the audio quality. So we were kind of like taking a look at this earlier, had some had two friends in the space as well, kind of sent this over this morning. And this is Podcastify AI. It's an open source version of NotebookLM. They even reference it here, or at least AK references NotebookLM here. And we are kind of listening to this morning, and this is not a drag on, like, I'm sure Podcastify is doing amazing work. But when you listen to the audio quality, it still falls short of the NotebookLM audio model. And there's kind of three things that I'll call out that make the NotebookLM experience feel more realistic. And Harrison, add more onto that. But my three are, I think, the inflection. So the audio kind of going up or down, the way humans talk. The way that the pace of speech sometimes being faster and slower, and the ums, and the like you kind of call them the disfluencies, but like the way that we kind of find ways to, like, maybe there's like vocal fry, or I'm talking over you a little bit, or you talk over me, but the way that the audio sort of adds these little nudges that feel more human-like and feel less perfect. um like just what I just did there. So that's part of the audio model, I think, that product wise makes it really stand out.
Yeah. I think for me, it's a few things. And by the way, it's funny to see, like, like Karpathy will tweet about how much he loves Notebook LM. And then you see all the other like solopreneurs or something. It's like, well, like I created PDF to podcast like 3 months ago, and you post a link to it. And like it's just funny to see everyone getting worked up, because I bet 100, maybe 1,000 people have this idea, right? But I think the execution of the model matters a lot. Just like you said, I think humans are really good at attuning to whether or not someone is real. And this is like the last 2% of 98% human-like is really important. I think the technical piece of it, and if we get into the paper, there's this huge technical component about, like, there is a computational constraint on how long of a podcast you can generate. And there's this trade-off between how good you can make the audio quality and the duration. And I think even in this one, you can see the duration is not very long, it's 3 minutes and 40 seconds. So I think there was a technical leap there. I think there's also this like distribution advantage that, that like Google just has. I can hear about NotebookLM and I can just get it up and running, my Google account, and I
Yeah.
can just have it chat on like Google Docs I already have. It takes 5 seconds versus a lot of these other products people talk about. It's like, okay, I don't know. I guarantee you Podcastify.ai, I have to pip install something, right? Like, I have to pip install this. I gotta like download something from Hugging Face. I think that gap is pretty big and I think plays into it. But yeah,
Yeah,
conversation
totally.
matters a lot.
I think it's really funny. Like Noor in the chat says it's all deep fake webinars from Arise from now on. I mean, so like two thoughts on that. One, we actually thought the initial pitch on this podcast, on this episode, was what if we just fed the paper into NotebookLM and put that up as like the episode and see if people notice. But I think we realized, oh, we should probably actually do a little bit more work than that. Try to automate our jobs a little bit here.
We did have this existential crisis. Like, why even freaking do this up?
Yeah, exactly. Exactly. And then we realized like, oh, actually there are ways to improve the experience. So another thing we tried was we played this it doesn't come out very well because there's no recording of it, but we had NotebookLM in the background and we had O1 sorry, not O1, the real-time audio from OpenAI on our phone. And we were kind of trying to see if there could be a discussion, from like a little bit of the NotebookLM, going to O1, going to the real-time audio and then back and forth. But it is interesting. I think that the maybe for me the killer feature is the fact that these audio streams slightly talk over each other and they have these moments. They have it kind of feels like they have moments that even with real-time audio feels like, even though it's mind-blowing, it's so crazy how it's like a low latency audio stream and text to speech, it's still lacking a little bit of that like humanness. So that humanness quality. Okay, so I think that's most of what we can rip on the product side. I think now for the people in the room, I have a feeling that there's a desire to get into the technical. So let's turn this NotebookLM episode a little bit more technical. Harrison, what are your thoughts on SoundStorm?
Yeah, let's see. Let's see the AIs do that. They probably will. We're gonna try and talk about this paper called SoundStorm, which is again from the outside looking in, but many people speculate this is the model that NotebookLM is using to generate the high quality audio that we hear from NotebookLM. And so what does it, let's start by framing it clearly. What does it actually solve? Like there are text-to-speech models out there. What does SoundStorm specifically solve for NotebookLM? Kind of gets to what you were saying earlier, right, Aman? Like the power is like the consistency. It's like the same host over a long duration of the episode. And hopefully, the paper's pretty dense, but hopefully what this audience can get out of this at the end is understanding how these two things were trade-offs and what the technical innovation from SoundStorm was to push the boundary of this like consistency in terms of the speaker's tone, the timbre, the pitch, and the duration of the episode. So let's go to the next slide. Before I talk about RBQ, just the quickest primer on sort of text speech. The fundamental unit of data is like this frame, like of a recording. So it's typically, like 20 frames per second, just a clip of the waveform that's encoded into, let's say a vector. You can think about it as like the embeddings for length of speech. That's the token in this world. And a really clever thing that SoundStorm exploits but did not invent is this thing called RVQ, residual vector quantization. The power of this way of representing the token is that it's hierarchical, which I'll get at in a second. So at the root of this is there's this thing called a code book, which is sort of like you can think about like eigenvectors of all possible ways that a sound can sound like. And so there might be a vector that represents pitch in a certain direction, another vector that represents timbre in a certain other direction, or phenomes in another, yet another. But they span as much of the latent space as possible. And what RVQ does is it takes that vector, which is the embedding of the audio frame, and it quantizes it according to the codebook. So in this example, you take the vector, you quantize it to the vector it's most similar in the codebook. Maybe it's the fourth one, and you get out the number 4. So we've quantized it, super low dimension. Obviously, the number 4 is probably not representative enough. So it will do this repeatedly. Go to the next slide, Aman. So same example, vector representing the frame comes in, quantize it the first time. Maybe it's the number 3 representing the third vector in the code book. And then you do a subtraction, which is the residual. And then you repeat the same process on that residual. And then again, and then again, and then again. So each time you're capturing more and more information about the audio frame, such that the first vector is the most information rich. So this could be like I'm not an audio like expert, but phonemes, which apparently is like the smallest unit of distinguishable linguistic speech, all the way to really, really fine aspects of like pitch and timbre, or things that a person can identify the speaker with.
Is there any analogy or any relation to like compression happening here? Or is it really more of expanding on the data that you have? Or yeah, how would you like, what is the, yeah, it seems like you're like changing the representation of the data with each pass. Maybe you can like talk about that first.
Right. It is compression in one sense, because you can, the green rectangle on the left is this dense embedding, again, representing the frame. The thing on the right is just 3 numbers. And, you know, they tell you which vector from the code book it is. But the most important part is, as you read from left to right of this vector of 3, 12, 91, 3 is the most important part. It might tell you that it's a k or a f or a sound. And then 91 all the way on the right could be like, was it intonated up or intonated down? So coarse to fine.
Yeah.
And the way you can imagine it is like they are layers of the compression. And maybe if it was image 3 would give you a really blurry image, right? 12 would give you like a slightly more detailed image, and 91 is a super high fidelity 4K picture that tells you, oh, there's a frog on, you know, sitting on a leaf or whatever.
Kind of feels like when you're using Midjourney, you know, you can see each kind of shows each pass, it like starts kind of grainy and like just high level colors and just gets refined and refined and refined, kind of similar.
Right. That, but for audio.
Yeah.
I just led with
Cool.
that. For the...
Yeah.
Okay, so just we'll try and keep that in mind. No, I think we're ready for the next slide. So you have this thing called RVQ of an embedding. So as an engineer, you know, I'm not like a total research scientist. So I usually think of these things in terms of interfaces, like what actually goes into the model, what is the shape of things that go into this model, and what comes out of it. So what goes into SoundStorm is, first of all, what in the paper they call conditioning tokens. So conditioning tokens, you can think as they're embeddings generated from an upstream model that takes text and converts it to embeddings that capture the most coarse-grained aspect of what an audio frame would sound like for that text. So in this case, it's this other model called NotebookLM. Let's say you have this example where it's speaker 1, hi, how are you? I'm good, that's great. So the upstream model converts it to these conditioning tokens. And again, there's going to be, because they're very coarse grained, they might capture the and the but they'll capture nothing about any human's voice. So they're super coarse grained, very low bit rate. The second component that goes into this model is a one, or, you would, maybe if you're trying to mimic my voice over the speaker one, speaker two, I would say hi. And maybe you would say, how are you? And these will be converted to the SoundStream RVQ vectors that we were just talking about, all the way up to the finest layers that has like identical characteristics about how I speak, how you speak. And then the magic comes in where you will align each token. So the conditioning token that just captures the content of what's being said with the RVQ vector that captures all the unique characteristics of us. You line it up, and then the model decodes the rest. So go to the next slide now. Okay, so how does the model do it, and how does it exploit the structure of RVQ to address the problem we were talking about in the beginning, consistency over a long duration? So with those of us who are kind of familiar with LLMs, we automatically think autoregressive models, right? Like I might decode the first frame, then decode the next frame, and then the next and the next. And each time I'm decoding all aspects of the RVQ token from the coarse grain to the finest grain, and I'm doing it one by one. The trade-off comes in to the fact that the attention heads now have to attend to a lot more of the sequence because of how fine I'm looking at each token. Now, the way that SoundStorm exploits the property of RVQ is they have the transformer do self-attention over the whole, like if you think about it in terms of the x-axis of time, it decodes it all at once for the first level of the RVQ token. Let me try and see if I can annotate this. So in this thing here, you have time, which is, you can think about the episode going from 0 to when it ends here. And Q1 is like the first level of quality, Q2 is the second level of quality, and the third. Again, we're going from coarse grain to fine grain. Now, the autoregressive case would have you decoding this token, and this token, and this token. So you would be able to decode the frame with exactly the identical characteristics of the speaker, but you can't go on for too long because you've used up all the attention mechanism going vertical, so to speak.
I see. So
Yeah.
the limitation is back to attention in this case, in the transformer architecture.
But the way it beautifully exploits the RVQ is it says, no, well, why don't I just decode the first layer while having self-attention throughout the entire sequence of tokens from 0 to time t. And so it figures out all the layers here. And because it's doing that all in parallel, it's consistent over a longer time horizon. And so you're gradually then decoding the second layer here and third layer here with a key that at each layer, because you're paying attention to the entire sequence, you're maintaining a very consistent, representation of the sound of the frame.
Yep. And what's the consistency component of this? So it's like consistency in terms of this is the speaker and what they sound like. Is that sort of what that is?
Correct. Like in a model that doesn't do this, the way you would experience this as a listener could be that speaker one at the beginning of the episode sounds like, like a man. And at the middle of the episode, it might sound like a woman. And at the end of the episode, it might sound like a child or something like that. There's nothing that guarantees that it has the same characteristics of speech throughout the whole thing, unless you look at and self-attend to the entire duration of the episode. And so it makes it that you can not have this trade-off between the quality and the duration by building up the quality over time.
Yep. And that's where the role of the conditioning tokens as well. It's like these are the things that are like nudging. This is Harrison's voice or Aman's voice or something like that.
No, the conditioning token is a little more abstract. it has no identifiable characteristic. I would say that like the first layer of each of these like SoundStream tokens are probably what starts to give it a certain identity. And remember, the input to this model is you and I might say a few of the first parts of the script completely, right? And so it could be that time one and time two, these tokens are fully filled out. And so as the model's filling them in, it's kind of based on what this sounds like here and here and here.
I see. Okay.
Yeah.
Got it.
All right. That's
Cool.
that's basically it. The paper goes into a lot more detail about a lot of this, but I think for me, that was the most interesting takeaway of how they maintain that consistency.
So let me ask you, Harrison, did you use NotebookLM to understand how this paper worked, or what are the mechanisms underneath the paper, or did you try that out?
You know what? I kind of have a hot take on this. I didn't. I think for the parts of the paper, I think if you, I think so. I did and I didn't. So I did because the initial conversion of the paper into audio was a nice introduction. But as I was trying to understand, oh, what is a conditioning token? What is a, what is a conformer attention head? I could I could use NotebookLM like chat on docs feature, but I didn't find it that useful. And this is a kind of a hot take because I actually think just pasting the PDF of the paper to ChatGPT and talking over it is better because I think there's less of ChatGPT tries less to anchor on like, oh, I'm saying this because I'm referring to this part of the text. But products like NotebookLM will. Like that, the whole value proposition is everything you get from it is anchored to a source.
Mm-hmm.
And I think that's important when you're doing research. I think it's less important when you're trying to learn something. When you're trying to learn something, I think it's okay that you get analogies or explanations that are sort of not true, that you might consider hallucinations, but hopefully you're good enough of a learner to like go and kind of like double check on them and then kind of bottom that out for yourself. And I think that's the case for learning a bit of hallucination on the product is a good thing. So
Yeah.
uh,
I mean, like to build on that for a moment, like the text version and the audio version of NotebookLM are actually pretty different in that way, right? So in the audio
mhm,
version, you get this transcript. And I found actually, we were talking about this earlier, right at the start of the call, but like I put in my LinkedIn profile and it was like, whoa, this is cool. They're talking about me. And then it would just start making stuff up. And it was
oh,
truly
interesting.
like a
Yeah.
hallucination in the sense of like, in the sense of the rationale of some talking point. Like it was
Mhm.
like, oh, like, and then he moved from San Francisco to New York to like start this new job and like,
Yeah.
it started like coming up with this like story of um and then it would build on top of that. That became the new anchor for some part of the segment of the audio file. But in the
Yeah.
text version, yeah, it cites sources extremely generously and says
Yeah.
this is why, this is why, this is why. So I think those are
Interesting.
two discrete experiences too, where
Yeah.
it really depends what you're trying to do. But um, that was one of the things that like I was hooked, and then I was pulled back out of the experience actually because it was hallucinating about my life, and that really was existential. I was like, did I do that? I don't think so. But
That's it. I
yeah,
did not think about the two in the NotebookLM product. Think about those two parallel tracks. That's super interesting.
yeah,
Yeah.
yeah. And so I think that's part of it too. Is like there was a question in the comment. And
Hmm.
one of the questions was, don't you think there will be sliders in the future, like number of hosts, gender? I mean, I think the we were kind of speculating like probably the next thing that would make sense here would be like you being able to converse or interject, maybe this experience getting more real time on the audio side, similar to the chat
Hmm.
experience. Like if you think about the use case, it's like you're gonna have questions as the podcast hosts are discussing the paper, and you can ask them, oh, well, how did you get there? What's the analogy? Maybe having follow-ups or expanding on a point. So it kind of feels like product-wise, that's perhaps one of the directions to go. I also
Yeah.
think like hallucination and quality of the ideas generated is something that like one of our takes was like, it or one thought here is it actually a good podcast episode? Like, is it something that you would keep coming back to? What's the staying power of this product
Yeah.
versus this format where, it's a little bit more, there's a bit more randomness, a bit more organic, to it. It's a bit more organic. Like, what are your thoughts on that, I guess? Like,
I think in the end, if I was a consumer, I'd be less interested in trying to like dial up the number of hosts or like the tonal qualities. I kind of want that to be left to the, I'll just call it creator to decide, right? Like I think what will be interesting about these class of products is the pseudo relationship you build with these people over time. Like, why do we, like, half the podcasts I listen to, I don't even like the content anymore. I just kind of like the people talking about the certain thing. I don't think you'll necessarily want to change that as a user, but I can see having features that are like, I can interject in the episode and turn the direction a slightly different way that I'm interested in. I
yeah,
think it's a separate question for like, I think there's no doubt someone's going to create a set of tools that are amazing that allows you to adjust the tone, qualities, and mood. And I think will be interesting to see in the next few years is not the prevalence of like pure AI podcasts, but I think there'll be podcasts that are like 80% real and like 20% like post, right? Like people talk about that in the movie industry all the time. Like, oh, like we'll get that in post or editing. And there's like a certain number of frames that you film like on a
yeah,
soundstage. It's like half the movie is like visual effects. I think that's probably where we're gonna go. It'll just get really, really convincing.
yeah.
That'll be the interesting thing to see play out.
I mean, even if you just look at like, I think what another component of podcasts, which is interesting, is if you're listening to this on Spotify versus listening to us live or on YouTube, it's actually a pretty different experience. You kind of anchor on, do you like this person's voice or not? Do you actually want to keep hearing them talk? And
Yeah.
then do you know them? Can you relate to them? So to me, there's this interesting component of like, if you just focus on refining the quality of the audio, it's probably easier to some degree than like trying to create this like convincing, persuasive video format.
Mhm.
So riffing on that for a moment, like one amazing product use case I think was maybe an obvious one here is imagine a Joe Rogan or one of like an incredible podcast host cloning their voice, then create personalized ads for you as you're listening to the podcast episode.
Yeah.
So based on some format, here's AG1 or something like that. And I think that instead of going and, Joe Rogan going and recording, 30-second clips for 10,000 products, he can just clone his voice once and get 10,000 personalized ads that are way higher value.
Yeah.
So that's one,
Big time.
I feel like kind of, and similarly, you could say like, I want Joe Rogan to talk about the latest Jurassic Park movie.
Mhm.
So, you can create an episode, maybe it's a bonus episode or it's specific, it's a sponsored episode, but it costs him
Yeah.
nothing. It costs him
Yeah.
$0 to do that. So
Mhm.
I think that's an interesting aspect
Yeah.
of this that feels like it's like testing the waters product wise.
Interesting.
The
future of IP is like guarding your personal RPQ tokens. Yeah.
your weights. It's all about
Yeah.
protect your weights. And then there was a question of like, what point should hallucination be curved? I think like the interesting component here is like the hallucinations are simultaneously a detriment and a feature. They're like the bug and the feature in this experience because you kind of
Yeah.
want some amount of the temperature to be higher for the generation to have a more interesting, slightly off the topic conversation.
Yeah.
I think that's part of the feature of this. Yeah.
I think there's an interesting one to talk about maybe in a future paper read about like some of the frontier, what people are doing to reduce hallucinations though. There's some really exciting stuff.
Definitely. Yeah. Cool. This was a fun one. Maybe we should feed the transcript back into NotebookLM and post that and see what it comes up with.
That'll be a fun one. Yeah. Cool.
All right. Awesome.
Thanks,
Thanks,
everyone.
Harrison. Thanks, everyone. See ya.